There is perhaps only one equation in all of physics that almost everyone knows, and that equation is E equals mc². When you get down to it, it's actually pretty amazing that this particular equation is so well known. After all, it makes a pretty weird assertion, which is that energy is the same as matter. I mean, that's what the equal sign says. So given that the equation is so familiar, it's probably worth asking the question, is it right? And the answer will probably shock you. It's no, or perhaps more accurately, the equation is a special case. In order to use it properly, you need to know more. Now, I don't want my email inbox to explode because I said that E equals mc² is wrong. And you shouldn't think that I'm saying something controversial here. Anyone who has mastered special relativity will agree. The problem is not with the theory, but rather simply how the well-understood theory of relativity is portrayed in popular culture. So, if E equals mc² is wrong, what's right? It turns out that there are two more accurate but similar equations. Let me tell you about both of them. The first one looks pretty similar. It is E equals gamma times m times c². I made another video in which I talked about relativistic mass, which introduced this gamma term, and I made yet another video that talks specifically about gamma. You can watch those if you want to learn more about them. However, I can give you the high points. Gamma is a term that is ubiquitous in relativity. It is defined as 1 over the square root of the quantity 1 minus v² divided by c². V is an object's velocity relative to u, and c is the speed of light. If v is 0, then gamma is just 1. So that's your first insight. E equals mc² is only correct if an object isn't moving with respect to you. And as an object's velocity increases towards c, gamma gets higher and higher, and the energy of the object increases. Note that the mass doesn't increase, but the energy does. This is a particularly important point to realize, because I don't know how many times people tell me that since energy and mass are the same, then a highly energetic object is also a massive one. At least not in the way that most of these people mean. It's just not true. So get that misconception out of your head. There's another aspect of this equation that people get at least kind of sort of wrong. If you keep the energy constant, but reduce the mass of the object, then the gamma must increase. And if you take the mass all the way down to 0, then the velocity must become the speed of light, since gamma must become infinite. This is because you start getting into mathematical tricks where infinity times 0 equals a constant. So that kind of works in calculus, but invoking infinities in physics is usually a very bad idea. Thus, this equation doesn't really apply for photons, which are massless particles of light. Indeed, and this is an important point, this equation only applies for particles with mass and for speeds below the speed of light. Now, there is another equation that applies universally for both particles with and without mass, and that equation is here. It is E² equals p times c, all squared, plus mc², again, all squared. The meaning of the symbols is E is energy, m is mass, what some people call the rest mass, but is really the only value for mass. C is the speed of light, and p is the momentum, which is a measure of the motion of a particle. Let's see what happens in the case of a particle not moving, which means setting the momentum to 0. Voila! You get the familiar equation E equals mc². Now, let's set the mass of a particle to 0, which, of course, describes a photon. We see here that the equation turns into E equals p times c, which is the correct relationship between energy and momentum of a photon. That's pretty snazzy too. Further, this equation demonstrates precisely why using the E equals mc² equation for photons is just simply silly. If you do that, small children will laugh at you. So don't do that. By the way, there's one additional point that I'd like to make. Let's go back to the other equation relating energy to mass, the E equals gamma mc² one. Yeah, that one. Commenters in previous videos asked for a physical meaning for gamma, and this is at least the way that I think of it. Remember that mc² is the energy of a particle at rest. In contrast, E is its energy while it's moving. Thus, gamma is simply the ratio of the total energy of a particle to its energy when it isn't moving. Since particle physics experiments often measure a particle's energy, I find this particular physical implication of gamma to be the most useful. So that's it. Einstein's most famous equation is true, but it's actually a special case of equations that apply more generally. And now you know how to do it the right way. Relativity is really pretty mind-blowing, no doubt about that, and it's misused so often. I hope that this video helped you out. If it did, please like, subscribe, and share, and tell all your friends. We have to get our numbers up. And feel free to comment. We want to hear what you have to say. So see you next time, and remember, physics is everything.